Okay, so today we're going to talk about isometric and orthographic drawings. All right, so what I want you now to consider is drawing a prism with these dimensions. A prism is like a box, right? And this prism is going to be done in such a way that it's going to have a 3 by 2 by 1 height. Okay, let's see how you would do it. Okay, now if you drew it, you probably go, okay, this is 3, and then this is 2, and then the height is 1, and then we kind of connect the dots, right? And we think, okay, all right, yes, that's the way it is. But maybe somebody else, when they draw it, when they draw their work, they go and say, okay, it looks like this. This is 3. This side is 3. This side is 1. And then this side of my box is 2. So now, the box looks different. Looks a little thinner than the other, right? So your drawings, when you do them, are not always the same as to others, right? Because your length and width might be decided upon as different, okay? So today, what we're going to do is we're going to take a little bit of time to work on 3 possible ways to represent that figure, okay? So right now, we're going to start working on our first concept called isometric drawing, okay? Now, isometric drawing is important as it's drawing in 2D. It's a 2D representation of a 3D figure. We kind of did it when we started our lesson today, okay? The drawings look like a 3D figure has been rotated so that there's a corner view so that you can see the top, the front, and the side of the figure at an angle, okay? This is what the rectangular prism is going to look like when you have an isometric drawing with a scale of 1 and unit 1, okay? So this grid that I have here is an isometric grid, okay? If you ever need one, send me an email and I'll send you a copy of one. Okay, you can always find them online, and when the time is right, I'll also make sure there's one available on the website for you. Okay, so just remember that the distance between these two things here is exactly 1 unit. So this would represent 1 meter. So like I said here, the unit, 1 unit was equal to 1 meter here, okay? So the scale always has to be stated when you go and do your drawing, okay? So in this case, since the scale has been set to be 1 for all those different numbers, right? That means that this unit of 1 meter here, which is important, means that this side is 3 meters, this is 1 meter, and this is exactly 2 meters, okay? Now, imagine if I asked you to look at this graph, look at this nice little mesh graph that we have here, and what I want you to do is I want you to imagine that you're going to go and create a 5 by 2, sorry, a 5 by 4 by 2, 5 by 4, 5 by 4 by 2, where this 2 is the height. Okay? Okay, so where that 2 is the height. So I want a 5 meter by 2 meter and by 4 meter width box. Okay? Length, width, and height. All right, so in order to do that, what we're going to do is we're going to start at a corner and we're going to go and look at the length of 5. So I want to have my length to be 5 units. 1, 2, 3, 4, 5. Okay, so there's my 5 units. Okay, then we also have to have its width being 4. 1, 2, 3, 4. Then in order to make this box kind of work nicely, I got to go and make a parallel line. And this is the top of the box. So imagine if this is the top of the box. What would happen is I would have to draw down to get my height of 1, 2, and then I'd have to mirror the 4 distance on the bottom. And 1, 2, 3, 4, and then connect the front face of the box. Now to finish the box, to finish the other side of the box that we see, we got to go and add a height to this ledge and then connect this portion of the box. So we end up with a 2 height, a 4 width, and a length of 5 meters, right? Where 1 meter was equal to 1 unit on our isometric graph. So basically what we had to do was we just had to draw the edges of the object, right, along the angled lines, and each segment of the line each segment of the line was related to 1 unit of measurement, right? Now when we did this, we always said that our length, width, and height is going to be read in that way. Length, width, and height. Okay? Now, let's move on to a concept called perspective drawing. Okay? So, we already studied isometric drawing, which was using that grid pattern to help us easily draw something in 3 dimensions. Okay? And I will provide isometric paper for you. But there is another way to draw. This way of drawing was first used by a person named, I think you've heard of him before. I believe it was Galileo that came up with the concept of that, or he used it in his paintings at some point. Now, the concept of isometric perspective drawing is a way to make a 3D figure in 2D. Okay? It's similar to isometric drawing, but all of the parallel lines of the figure are slanted off to a point. So you see this point here, right? Imagine that we were drawing a picture, and all of the shapes that are going to be drawn, okay, in the following picture are all going to be related. All of the parallel lines are going to be following the lines to the far point in the distance. It's kind of like when you're sitting on a train track and you look down the straight line of the train track, it kind of disappears off into the distance, but you know that the two lines that represent the train track are parallel and they never touch. It's the same concept here. So this is what a rectangular prism looks like, okay? And this point here in mathematics we call this projective geometry. This point here is what we call the vanishing point, and we use the vanishing point in relation to anything that we draw with parallel lines in any picture in any box that we create in our picture, and it gives a sense of realism to any picture that we draw. All right, so to create a perspective drawing, you have to draw the front view of the object, right? So, for example, we'll do that right now. Okay, I'll draw one a little different from the note, but I'll draw one with using the current perspective, okay? So imagine that I go and make another box, and my box is going to be here. The face of my box is going to be here. So the key is you draw the face of your box, okay? And you'll notice that I kind of put my box at a certain angle. And then what I do is every line that needs to be parallel follows the line directly from the vanishing point to the edge. So you could literally just draw them in to kind of see where our edges for our new box are. So now when I go to draw the rest of the box, I have my edges well defined. Now what that allows me to do, it allows me to go and make my edges exactly parallel to those vanishing points. But remember, here is my height. The height, I have to follow the same parallel to that on my other box. And then I have to follow the same edge that I have here. And then this other edge that goes towards the vanishing point, I just extend my line from my edge to there. And now we have another three-dimensional box, and we have two boxes, kind of one to the left, one to the right, of the perspective of the viewer. Okay? So what I essentially just did was draw a 5 by 4 by 2 rectangular prism. Okay? That's literally what we just did there. Okay? Now, that's what I did in our picture, right? So what you're going to do in the space below is you're going to try drawing a 5 by 4 by 2 prism exactly the same way on your own. You saw how I did it. You're going to have to set up a point. Then you're going to have to draw the face. So one, you draw the point. 2, you draw the face. And then I guess 3, you draw the lines, draw dashed lines, dashes to the corners, and then extend your lines, and then you're done. Okay? So I'm just going to zoom out, and I'll show you where your box is. So there is the dot. All you have to do is draw a box, the front face of your box. So there's the front face of my box, so it's right in front of me. And so now we know that the height is 2, the length, the width, and the height is there. So now the width The height is 2. I guess this would be our, let's make this our width, okay? And then our length goes into our thing here. So I'm gonna go and get my different colored pen. I'll use red this time for my dashes to the corner. And then all I have to do is draw back towards the vanishing point. And I've got something that, so if this is, what did I say? If this was 4, and then this was 2 meters, and then this part here has to look a little longer because it's kind of going into the background, right? So we're going to say that this is 5 meters. And we're done. So make sure that you do something like this, right? Okay, and as you get better, you can start doing some weird stuff where you can kind of make like a parallelogram, and the parallelogram makes the box looks like the box is shifted off to the right, and then you can still draw a nice box using the parallel, using the perspective drawing. Okay, all right, move on to the next concept. All right, so when we're talking about orthographic drawings, we're actually talking about getting the top, front, and side view of an object, okay? So imagine we were looking at our object that we had, at an object that was defined by this. Imagine going from left to right. The width, the dimensions were, let's see, 3 by 2 and then by 1, where the length was 3, the width was 2, and the height was 1. Okay, now this is what the top portion of my box would be. It would have to look like 3 by 2, right, on this nice little grid here, because it would have to be 3 meters, which is 1 box unit, and by 2 meters. Okay, so that's what those things mean. Now remember, the front of this thing, I'm going to say, is along here. Okay, so along there we have 3, and then when we're looking at it from the side, i.e. the front side, basically we've got the height of 1 and its other base of 3, okay, where it's 1 meter by 3 meters. Now if I wanted to look at the right side of the box, the right side of the box is going to look like this. It's going to have two meters up here and 1 meter for its height. Okay, now I have a challenge for you. Okay, you just got to remember that when we create an orthographic drawings, we need to create an individual scale drawing of each of the top, front, and the right or the left views. Okay, it's up to you. Okay, just make it happen. All right, so imagine if I give you another problem where I ask you to draw something that has the following dimensions: 5 by 4, so 5 meters by 4 meters by 2 meters, just like before. But what I want is, remember, I always want you to give me the top view. Okay, you know what? I'm going to make sure I just write this in a different color. So this one was our top. We had our front and we had our right side. So we're going to follow the same pattern. So we got to create the top. The top of our box is going to be, pause the video and then draw what you think it's going to look like, and I'll show you what my answer is. Okay, here it is. So we have a 5 by 4. Okay, so it's 5 by 4. So then we also need the front side. So let's see. Pause the video and show me what the front side is going to look like. So in this case, when we're looking at the front, this time we can see the height, right? So the height is going to be 2, but the width is still 5. All right, now let's see what the right side's going to do. So I'm going to do the right side. And you're just going to pause the video, do your own interpretation of the right side, and then we're done. So on the right side, you can see that your width is not actually 5, it's going to be 4. Okay? Its width is still 4, but its height is 2. And I think we are done. Now, your homework is going to be the handout that I prepare for you, okay? You'll see it as a link on the web page. Take care.